Solve integral of 5x times exponential e raised to negative 2x dx to a limit of 1 to 0. We are going to be solving this integral of 1 to 0. We have 5x exponential e raised to negative 2x dx. We are going to solve this by using integration by parts. So if we use integration by part, don't forget that integration by part formula is integral of u dv is equals to uv minus integral of v du. So we have that. So since this is the integration by parts formula, we are going to split this. We are going to be splitting this one into this u and v. So let u be equals to 5x. So if u is equals to 5x, we can get our du from here. That is to differentiate this so that we have du dx to be equals to 5. So the differentiation of this is equals to 5. Now let's make our du the subject of this formula. Let's make our du the subject of this formula. So if you do that, just cross multiply this times this times over 1 here. So you have our du to be equals to 5 dx. So that is the value of our du. So we have u, we have du. Now we move on to the next part. Let's call this other part v. Let's call that part dv. Let our dv be equals to natural log, that is e raised to negative 2x. Okay, e raised to negative 2x. Now we are going to integrate this. So if we integrate this and integrate this, so we take the integral of this and integral of this. So if we do that, we are going to be having v to be equals to integral of dv will give us v. So integral of e raised to negative 2x will be giving us e raised to, okay, minus e, because we are going to use this minus e. We have minus e. Okay, let me rewrite that. That our v will be equals to minus e raised to negative 2x all over 2. So we'll be having that. So when we integrate, we'll have that at the end of the day. Now the next thing we want to do here is to substitute all this into this our integration formula, integration by parts formula. So we substitute all this into this so that we now have that what we were requested to solve, what we were asked to solve, integral at a limit of 1 to 0 of 5x exponential, we have 2x, okay, dx. Now this will be equals to, so let's substitute this now. So we have our u is 5x, okay, times, so let me use dot for times there, times our v is minus e raised to negative 2x all over 2. Okay, so minus our integral. Don't forget this integral is given to us in 1 from 1 to 0, from 1 to 0. So let's try to write what we have there. So we have our v again. We have v again from this place. So I'm just substituting. We have v again there. Our v is minus exponential raised to negative 2x. Okay, then all over 2. That is our v. That is what we have as our v. Now our du is 5 dx. That is our u, our du. So this our du is 5 dx. So we have this. Now let's quickly rearrange this. If we do that, we are going to be having our minus 5x exponential raised to negative 2x, okay, all over, okay, let's say everything over 2 here, okay. Now we have a minus here. Let's factor out all the constant. We have 5 here. We have 5 as a constant here. Now we have minus here. So this minus, so minus 5, we'll factor out that. We'll bring that out before we even integrate. So we have minus 5, bringing it to affect this minus, become plus 5 integral of 1 to 0. And we will now be left with exponential raised to negative 2x all over 2 dx. So we can go ahead and integrate this now. So from what we have solved, we can go ahead and take the integral of this. So let's repeat what we have. Let's rewrite this. So by the time we rewrite all this, we will be left with, let's move on. So we will be left with, we are actually going to substitute all this, but let's take the integral of this. So we'll be having our minus 5x already, e raised to negative 2x all over 2. Now, when we integrate this, so if you integrate this e raised to negative 2x divided by 2, when you integrate this, you find out that you will be having minus 2 at, so if you integrate this, just integrate this up here, you have, when you differentiate this, use it to multiply. So you'll be having minus 2 here. So minus 2, you have a minus here. So if you integrate this guy here, you are going to be having minus, a kind of minus. So we'll bring the minus out here. We'll be having minus, because plus minus is minus, so we'll have minus 5. So all we need to do is to, for integration in the case of this exponential function like this, so what we need to do, by the time we differentiate this, this will be minus 2. So this minus 2s become minus 2, and we use it to multiply the denominator here. So if we do that, this will be minus 2. Minus 2 times 2 here, it will become minus 4. And we can take the minus outside. So that minus will affect, the minus there will affect this plus. So minus plus is minus. That is why we're having minus 5, minus and our 5 there. So we'll just be left with exponential raised to negative 2x all over 4. This is what we'll be left with. So this is what we'll be left with. That's what we have. And this is to this 1 to 0. So we have that. We have that. So if we do the same thing to this, this also affects this. That limit also affects this as well. Also affect this. So 1 to 0. I have to rewrite this so that we have it more clear. So let's apply these limits. So when we apply the limit now, we'll be having this to be equals to, we substitute 1 in one part, then we subtract it by another substitution of 0. So you know that normally if I substitute 0 here, everything here will become 0. But let me just do it for the sake of some persons. So we now have this to be, we have this. Okay, let me change this bracket to maybe a normal bracket. So that will now be minus 5 into 1. We have exponential e negative 2 into 1 all over 2. So we have that. Now minus, so we have that. So minus, we do the same thing. Now because of there is a minus here, so this will affect it. It will change it to plus. Because since there is a minus here, it will change it to plus. So we also have that. That will be minus 5 into 0. We have exponential negative 2 into 0. So we have that. Now everything all over 2. So that one is for this. That is for that. So let me group it. That is for that. Now minus. So let's go to this part. So we have 5. We have 5 now into the same thing. We have this exponential raised to negative 2 into x, which is now 1 for this now. So all over 4. Now minus, we are moving on. We now have minus. So there we have minus. So minus the same thing, we have exponential raised to negative 2 into 0, okay, all over 4. So we have that. So this is what we have. So let's go ahead and express this. So by the time we express this, we are going to have this whole place here. This will become minus 5 times 1. That is minus 5 exponential minus 2 all over 2. So we have that here. Now everything here, by the time you deal with this raised to power 0, exponential raised to power 0 is by the time we do that, this raised to power 0, we come up with a perfect solution that we are going to use to get that. But you know that everything here will be 0, because 0 times everything up here is 0. So 0 times minus 5 is 0. 0 divided by 2 is 0. So that is gone. That is out for that. So we only have this in the first bracket. Now for the second bracket, we will be having this minus 5. We use this minus 5 to multiply whatever that is left from each part. So we have minus 5 to multiply whatever that is left here. So we have exponential e raised to negative 2 times 1. So negative 2 times 1 is negative 2 all over 4. So that will now give us minus 5 exponential raised to negative 2 all over 4. So we have that. We have that now. Now the same thing here, minus 5 times this. You know that minus times minus will become plus. So that is plus. That is plus. Now if we do the same thing here, minus 2 times 0 is 0. So we have exponential raised to power 0. Now exponential, this e raised to power 0 is 1. So when natural log is raised to power 0, you have 1. So you have 1. This exponential raised to power 0, you have 1. So that will be 1 over 4. 1 over 4. Now if we go ahead to take the LCM of this, let's solve this with LCM. So we have LCM of, we have 2, 4, 4. So LCM is 4. LCM is 4. So 2 we go into 4 is 2. So that 2 times minus 5, 2 times the whole of this will give us minus 10 exponential raised to negative 2. Okay. Now we have a minus here, so let's repeat that minus. So 4 divided by 4, or 4 divided by 4 is still going to give us 1. So 1 times the whole of this, we have 5 exponential raised to negative 2. Negative 2. Now we do the same thing to this other case. 4 we go into 4 is 1. 1 times 1. Okay, this is supposed to be 5 because we had 5 here. So let's correct that. This is supposed to be 5 because there was 5 here. So we just had to correct that. Because when we finish here, we have 1 over 4. So we're supposed to multiply by 5. So this is supposed to be 5. So we have 5 left there. We have 5 left there. Equals to. Now this and this are common. That is minus 10 e raised to negative 2 minus 5 exponential raised to negative 2. So this and this are common. So minus 10 minus 5 will give us minus 15. Will give us minus 15. Minus 15. Will give us minus 15. Now, and we have our e raised to negative 2. Negative 2. Then our plus 5. Our plus 5. All over 4. All over 4. From when we were solving this part. So we just need to kind of factor out some things. Now let's factor out 1 over 4 out. Let's bring out 1 over 4. So we are going to have 1 all over 4. I just had to shift this out. So like you are doing in a computer, so you just move this out. So if I factor 1 over 4, I'm going to have minus 15 e raised to negative 2 plus 5. Plus 5. So we have this. So I can as well rearrange this. So if I rearrange what I have here, I'll be having 1 over 4 into 5. 5 is positive, so minus 15 exponential raised to negative 2. So this is what I'm going to get at the end of the day. So this is my answer to this question.